Hey Hado and Will, sorry, the recording wasn't working at the beginning, but now it's tuned in. So we're just sort of going through exercise 6B. Finn, did you do these questions? You're all good with them? So you can have a look if you wanted to at 6G. We're sort of jumping, and I'll explain why in a minute, just so you're not twiddling your thumbs over there. Anybody else? Have a look, 6G. So equation of a line in 3D, we said we need two things, the direction vector and a point. And pretty much we started from question, so Eden, don't listen to this because I got you to start from question 4. Oh, okay, good. I didn't pop it up on Daymap. I got home on Friday. I thought, oh no, I didn't put it on Daymap. Then I figured it was too late. I was going to get up. I was going to go. I left my computer in my car, and I thought, oh, I'll go and do it. And then no, I fell asleep. So, so from question 4 onwards, and we're just going through 9. So the hint for 9 was the distance formula in 2D. We did this so we can extend it to 3D. We just add the z squared, sub your stuff in, and hopefully it solves. And then question 10, we want the shortest distance from a point to a line, and it has to be the perpendicular line, because if you sort of went there or there, it's always going to be longer. And again, we used our distance formula and the fact that if we have the equation of this line here, right, that's the equation of the line written in parametric form, but it means that any point on that line would actually be, that's your x value, that's your y value, that's your z value, okay? So we slap that into our distance formula. We will end up with a quadratic, and because we want to minimize, we're going to find the vertex, which is where the minimum is. So sorry about that. That was a quick summary. You should get 3 lambda squared plus 2. Oops, lambda. There is no b, so it's going to be 0 over 6, which is 0. And quite frankly, we could go ahead and do this stuff because this is, again, some of the stuff that we did with 2D vectors last year, right? Initial position, you plotted the points, find the velocity vector. So that would be, remember the yachts? So the velocity vector would have been 2 minus 5. Find the speed. How do we get the speed? You'd work out the magnitude of the velocity. So it's all the same stuff. We've done this, and you could do, but because we're just focusing on the equations of lines in 3D space, I just thought we would stick with that, and then we'd come back to this if that's okay. Like, I question the order of the wham. This is basically your vectors from last year investigation. It was just one question. We just turned it into an investigation. Anyway, I know, look at it, torpedo. So yeah, you could always come back and have a squiz at that. That's quite a thing. So we're not skipping altogether. I just thought we would stay on theme. And what we're looking at, I might regret it, but who knows? No, I'm not going to regret it. So relationship between lines, and we looked at this in 2D, and Will and Hado, I'm going to be doing a demo now and you're going to miss it. But yes, imagine this, I'm putting the rulers on a table here because we're 2D, all right? You just missed my visual that when we're talking 3D now, instead of just having these 3, we've now got the option that the lines can be skew. Now, with this stuff, again, you go, God, she's skipping more. But I don't know if you remember from last year when we did row operations, if you can do it for 3 by 3, then the 2 by 2 is really simple. So we sort of, again, we'll do that all in one shebang. All right? So as we said here, we've now got the fact that we can have skew lines, and that's a bit of a dodgy diagram because they're sort of, it's 3D, man, 3D. So you can see here, this example covers 3 different situations when we could be parallel but not coincident, right? So they're not on top of each other, but they're parallel. We're going to see where we can find where they intersect and get the angle between them and then show that the two lines are skew. Now, you don't really have to get the angle between when they're skew. That's only if you sort of push them against one another. But anyway, so show that lines 1 and 2 are parallel without looking. What part of our equations do you think would tell us if they're going to be parallel or not? Right, your direction vector. So if we look at line 1, I mean, they've written it now in vector form, but, you know, could you just sus 2 minus 2, 4? Oui? Okay, line 2, we've got minus 1, 1, minus 2. So you can see 1 is a multiple of the other, but that's happy. Why can we say that they're parallel and not coincident? Wouldn't the one point have to lie on both lines if they're coincident? So you can just check, does the point that we have here, minus 1, 1, 1, does that lie on the other line? Right? Sub it in. Does it work? If it doesn't, then they're not coincident. Yep. So you can just solve. Does that make sense? Okay, so now we're going to look at show that lines 2 and 3, and this is quite nice because it's just repetitive, and I was just thinking, because those of you who've got tests, what have you this week, just a bit mindless, don't have to think too much, right? Equating, right, we want to see, for starters, we're looking at 2 and 3. So when we look at 2 and 3, we write their vectors first. And we suss very quickly, so we've got minus 1, 1, 2. This is 2, minus 1 and 3. So straight away we've ruled out they cannot be parallel or whatever. They're either skew or they've got a unique solution. They intersect, correct? How do we find out if they intersect or if they're skew? You equate the x and the y values, and then you have to do and check with the z, all right? It does last. So we look at our x's first. So we come up here, 1 take t, and 1 plus 2u. So we equate, say that equals that, and we get, t equals minus 2u. Two unknowns. What can we do with that? So we then equate our y values, all right? So back up here, t and minus 1 take u. So we make them equal each other. So now I've got two equations with two unknowns. Simultaneous, guys. Use your calculator if you want to, or solve simultaneously, up to you, right? You can't leave it there because you actually then have to double check the values that you get for u and t. You actually have to sub it into the equating of the z. You can't forget that part. A lot of students will just do the x and y, go. They can catch you out just in case the z values don't. So double check, sub your values for u and t into here. Does it equal minus 1, or does the left-hand side equal the right-hand side? If it does, huzzah, we've got a intersecting, what was that one? We've got our intersecting point. If it doesn't equal each other, then they're skew. Okay? Doesn't work. Gonna be skew. Yeah. So once they intersect, go on and you can find the angle if it asks you to. Remembering, by hand, also by technology. Right? Remember to use your calculator. Get used to that sort of thing. If you are stuck, let me have ask me. And for part C, when it's saying suss if lines 1 and 2 intersect or skew, well, you do exactly the same process, but obviously when you are solving, it just won't work. Okay, so you'll get a value for u and s. When you sub it into z, doesn't work, so they're skew. So that's why it's essential to sub into your z component. Does that seem okay? So, sorry for, I just want to keep the equation of lines bit together. So please, once you finish 9 and 10, if you've still got issues with C for, what's it called, the angle, let me know, but you'll get practice again when we come here. So I'm going to solve yours at Mac, and then we'll carry on. Is that okay, peeps? Have a go. If you want me to go through it with you and do an example together, I can, but it's very much follow example, read example, follow example. All good. Oui? Love you. So we're just going through question 1 here. It's just like the example. All right, so the first thing that we want to check for is, are they parallel? So we're going to look at our direction vectors. So the first one, we'll go direction vector is now you can see straight off the bat they are not parallel. So therefore not parallel or coincident, right? Let's imagine I'm just saying that's A and that's B, since A doesn't equal K lots of B. You can't times one by a value to get the other. All right, so what we now have to do is check if unique or skew. And we do that by equating our x's, our y's, and our z. Okay, so let's take our x's first. So we're going to go x, and we're going to say that 1 plus 2t equals minus 2 plus 3s. So I just do put the 2t over here, take 3s, and get the 1 over, and we get minus 3, right? Then I'm going to equate my y's, and I've got 2 take t equals 3 take s. Put the t and the s on the other side, so I've got minus t plus s equals 1. So now we will solve this because I've got 2 equations and I've got 2 unknowns. Okay, we could do this by hand, but you know, we've got a few minutes left, so I'm just going to be a bit of a slacker. Grab my calculator. Go down into equation. Simultaneous. We got 2. What were my ones again? 2, 3, minus 3, 2, minus 3, minus 3. Minus 1, 1, 1, minus 1, 1, 1. Quickest calculator in the West. 0, 1. Okay, so we've got t equals 0, s equals 1, and now we must check and sub into our z, right? So we've now got 3 plus t equals 1 plus 2s. So I'm going to check now. Check by subbing. So on the left-hand side, t is 0, so I've got 3 equals, s is 1. 3, ha-ha! Right? Therefore unique. If this didn't equal, if 3 equaled, let's say we had s was 2, right? And so then we'd end up with 3 equals 5, but the z's don't equal each other, then we've got skew lines. Does that make sense? So now we've got our t and our s, so we can now sub it into either one of these to get our x, y, and z value. Right? So let's, obviously when t is 0, that's going to be the easiest one. So our unique solution, might as well just do here. So it'll be 1, 2, oh my God, 3. Okay, if you wanted to really check, if you chose s is 1 and you popped it into this one, and this one, you should get exactly the same answer. Okay, so when s is 1, minus 2 plus 3, yes is 1, 3 take 1 is 2, and so on. So that is our unique point of intersection. Do we have to now go and find the angle between them? We'll read the question. If you do, try doing it by hand. The next time you do it, maybe try using your calculator. But if you've done 6C, it's pretty much same thing. So you can choose, as long as you know, oh, yes, I can find the angle between two vectors, right? Save yourself some time.